Okay, so this is a video on congruent triangles. And we're also going to talk about two things called SSS and SAS. Alright, so let's get down to what congruent triangles are. If I have two triangles that are the same size and the same shape, then those triangles are congruent, which means that their sides all have to be congruent. The corresponding sides all have to be congruent, and the corresponding angles must all be congruent. That gives me same size and same shape. Now, we're going to use an abbreviation that we're going to call CPCTC, which stands for corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Okay, so hang on to that thought. It's going to be used quite frequently in the next chapter that we're doing here. We're not necessarily going to use it a lot today, but since we introduced the definition of congruent triangles, which are triangles that have all the same sides and all the same angles, we want to make sure that that's kind of introduced here because it's going to be relevant to our work going forward. Okay, so there's our definition of congruent triangles. So kind of the big question here is like, what do I actually need to know in order to prove the two triangles are congruent? So what is the sufficient condition? All right, so one of these is going to be what's called the SSS postulate, okay, which stands for side, side, side. And in this case, if I have two triangles, right, and I know the corresponding sides of one triangle are congruent to the corresponding sides of the other triangle, then it is sufficient to say that the triangles are congruent. So 3 sides of one triangle congruent to 3 sides of the other is sufficient for proving congruence. The other one that we're going to introduce today is the SAS postulate. And here the order of the letters matter. Okay, so this is side, angle, side, and the A, you'll note, is in the middle. Okay, so this is kind of important that you get this right, because you have to have two sides congruent in each triangle and the included angle. So the angle that makes up, that has those two sides as the sides of the angle. If you have that, then you are guaranteed that these triangles are in fact congruent. Okay, so here's the reason why we have to be careful about this. Okay, I'm going to show in a minute that if you have an angle other than the included angle, you have a problem. Okay, so let's take a look at why that is. Okay, so let's draw a triangle this way, right? And let's draw another triangle, very similar, this way. Okay, now if I put these two triangles on top of each other, I'm going to get this one, right? There's one. And then the other one is going to look like this. Okay, so this is the orange one in my drawing, and the one above is the green one. Okay, so note, this is the same size in the drawing, so this side has to be congruent to that one. Now all we did is we swung this from there over here. So that means this one is also congruent to this one. That angle is congruent to that angle because that's that angle in both drawings, right? So taking a look at what we've got here, it's possible now to have two sides and an angle, but that angle is not included, and these two triangles are not congruent. So you have to have SAS, that's happy smiley face, good, but this is really easy to see why these are easy to remember, okay? Because this is this and this is that backwards, okay? These two are no good. SSA and ASS, no good. All right, so happy smiley face for SAS. All right, so that's our idea for today, that triangles are triangles that have congruent triangles are triangles that have congruent sides and congruent angles. Two ways to get this are SSS and SAS, and we want to talk about the parts of them. We can use this abbreviation CPCTC, which means corresponding parts of congruent triangles are congruent. Okay, so there we go.